LR circuit, that is one of the application of first order differential equations. So to discuss about LR circuit, first of all we have to discuss some definition. That is first of all drawing circuit. So that is here we have in series inductance and resistance. So and also here voltage. Now this is circuit. In this circuit we have only resistance and inductance. Now, so in this circuit current is passing IB the current passing through given circuit. Now here actually I is equal to, that is dq by dt, that is the rate of change of charge. Now, so first of all we have to form a differential equation from a given differential equation. So how to form differential equation from given electrical circuit? So now in this circuit, I is the current is passing through this inductance and resistance. Now here voltage drops across resistance and inductance. What is voltage drop across inductance? Voltage drops inductance, that is L di by dt. So that is voltage drop across inductance. Next, voltage drop across resistance is Ri. Right? These are the voltage drop across resistance and inductance. Now, by voltage law. So, what is voltage law? So, the voltage law is the algebraic sum of voltage drop across a given electrical circuit, across given electric circuit L and R. Then that is equal to the resultant electromotive force. So, that is denoted with the E. Then, so by voltage law, sum of the voltage drops. Here voltage drop across inductance is L di by dt and resistance is Ri. Right? Now by voltage law, so what is the condition here? The condition is L into di by dt across inductance plus across resistance, that is Ri, is equal to resultant electromotive force. So that is here denoted with E. Right? So from this, now here write this equation as di by dt dividing with L. So here we get R by L into I is equal to E by L. Right? Now this is the differential equation from given electrical circuit, right? So now from this find solution for I. So how to find solution for I? Now clearly it is a linear differential equation. So what is linear differential equation? Actually linear differential equation general form is dy by dx plus p of x into y is equal to q of x. This is general form of linear differential equation. This is called linear differential equation in y. Right? Now compare with this equation. So here we have P is R by L and Q is E by L. Now solution for linear differential equation. What is solution for linear differential equation? So that is to find solution, first of all we have to find integrating factor. So what is integrating factor from this differential equation? So first of all write here P is equal to, compare with this equation. So here P is R by L and Q is E by L. Right? Now from this, so find integrating factor. So what is integrating factor? Now here integrating factor is e power integral P into dt. So here integrating factor is e power integral p dt. What is p? P is R by L. So substitute in this. So we get integral R by L into dt. Now here R by L is constant, right? So here we have e power integral dt. So then e power r by L is constant, integral dt is t. Finally, we get e power RT by L. That is integrating factor. Now, this is a linear differential equation. Now, write solution. What is solution of linear differential equation in I? Then the solution is the general solution is what is general solution here? So, I into integrating factor is equal to integral Q into IF with respect to T plus C, right? Now substitute integrating factor in this. So we get I into, what is integrating factor? E power RT by L is equal to integral, what is Q here? Q is E by L. Now substitute E by L, then IF is E power RT by L dt, right? So integration with respect to T plus C. Now here E by L is constant, then so it is e power RT by L with respect to T. Now it is in the form of e power integral AT. So integral e power integral AT is e power AT by A. What is A? R by L. Now here integration of e power RT by L, that is e power RT by L by A. What is A here? R by L plus C. Now taking denominator, this becomes L by R. So then here L cancel. We get E by R e power RT by L plus C. Now it is I e power RT by L. Okay. Now, so this is equation. Substitute both sides e power RT by L cancel. From that we get I is equal to, so E by R, so here both sides e power RT by L cancel, plus C into, there is no e power RT by L, then e power minus RT by L, or otherwise dividing with e power RT by L, so here e power RT by L cancel, here e power RT by L cancel, there is no e power RT by L, dividing with e power RT by L, take into numerator, we get e power minus RT by L, right? This is the current, right? Now, actually, if initially means when t is equal to 0, the current, there is no current. So then, if t is equal to 0, then I is 0. Substitute this in this equation. So we get, there is no I is equal to 0, is equal to E by R plus C into e power minus R by L into T is 0. From this, e power 0 is 1, 1 into C. That implies we get C is equal to, so transpose to left hand side, so we get e power minus E by R, that is C value, right? Substitute this in this equation, we get finally I is equal to, what is I? Here E by R plus C is minus E by R. Right, minus E by R e power minus RT by L. So that implies I is equal to E by R common, we get 1 minus e power RT by L. This is the derivation of LR circuit. So finally, from given circuit, so we can find a current, right? Now we are going to discuss one problem in this LR circuit, then that is, what is the problem, right? So first of all, problem is, right, first problem, a resistance of 100 ohms, 100 ohms, comma, and inductance zero point 0.5 Henry. 0.5 Henry is connected in a series with a battery of 20 volts, right? So a resistance of 100 ohms, inductance is 0.5 Henry, is connected in series with a battery of 20 volts. So here find the current. In circuit if initially current is 0. Initially current is 0. If initially current is 0, then so what is the current with the resistance inductance connected with the battery 20 volts, right? Now here resistance, inductance, so here voltage 20 volts, this is the required circuit. Here 20 volts given, resistance is 100 ohms, inductance is 0.5 Henry, right? From this we have to find current, right? First, what is the current by voltage law? Then the sum of voltage drop across resistance and inductance is equal to electromotive force, right? So that is here inductance L into di by dt plus resistance, okay, voltage drop across resistance Ri is equal to, so here E, right? So now this equation is di by dt plus R by L I is equal to, so electro E by L, right? This is equation 1. Now, so here given R is given and inductance 0.5 Henry. Substitute in this, we get di by dt plus what is R? R is 100 ohms, L is 0.5 into I is equal to E, voltage, battery 20 by L is 0.5, right? Simplifying this, we get di by dt plus, so 0.5 can be written as a 5 by 10, take into numerator, we get 1000 by 5 into I is equal to, here also, so 200 by 5. Now from this, so cancelling di by dt, so 1005 200 times is equal to, here we get 40, right? This is the differential equation. So what is the differential equation? So this is di by dt plus p into I is equal to q form, right? So then write what is p and what is q. So here write where p is equal to, p is given, what is p is? P is 200 and q is 40. Then first find integrating factor. So what is integrating factor? Here integrating factor is e power integral p dt. So that is e power integral, what is p here? 200 into dt, that is equal to e power 200 is constant, integral dt is t. This is the integrating factor. Now write the solution for a linear equation. So what is the solution for linear equation? Here solution is what is solution? Linear equation in I. Then write here IF is equal to integral QIF dt plus C. Now substitute integrating factor. So integrating factor is e power 200 t is equal to integral q is 40 into e power 200 t dt plus C. Right here integral. Now here 40 is the constant. Right. So this is e power 80. E power 80 integration is e power 80 by a. So here in place of a we have 200 plus C. Then if cancelling, so we get I is equal to e power I into e power 200 t is equal to here 40 e power 200 t by 5 times plus C. From this, so I is equal to, dividing with e power 200 t, so we get I is equal to 1 by 5 plus C e power minus 200 t. Right, this is the current, general current. But so here given find the current in circuit if initially current is 0. Initially means when t is equal to 0, there is no current, right? That's why here take when t is equal to 0, here I is 0. Now substitute in above equation. This is considered as equation 2. Substitute in equation 2. What we get here? So then I is 0 is equal to here 1 by 5 plus C into e power minus 200 into 0. Now it is e power 0 is 1 into C, that implies C is equal to, finally what we get? Minus 1 by 5. Now substitute this in equation 2. Therefore equation 2 becomes, so what is equation 2? This is equation 2. Right, I is equal to 1 by 5 plus C. What is C? Minus 1 by 5. So minus 1 by 5 e power minus 200 t. So then, so take 1 by 5 is common. I is equal to 1 by 5 into 1 minus e power minus 200 t. So this is the final current. Right? This is the process for finding current by given electrical circuit. Right. Here now we are going to discuss one more problem, that is so note down. Now we are going to one more problem on LR circuit. If a voltage of 20 cos 2t, 20 cos phi t is applied to a series. Write this problem applied to series. Circuit consisting of 10 ohms resistor and inductance 2 Henry. So then find the current at any time t. At any time t. This is our problem, right? So what is given here? So voltage is 20 cos phi t, resistance is 10 ohms, and inductance is 2 Henry. Right? The same process. Now, first of all, form the differential equation from a given one. So here we have inductance and resistance only. Then from this we get equation di by dt plus R by L into I is equal to E by L. Right? This is given equation from electrical circuit. Now substitute resistance L and inductance and voltage. Here di by dt is equal to di by dt plus what is R here? Resistance 10 by inductance is 2 Henry into I is equal to E voltage 20 by L is 2. Now simplifying this, finally what we get here, di by dt plus 5I is equal to 10, right? Now it is a differential equation. Linear differential equation in I. Now similarly, first of all, compare with the general linear differential equation. First write what is P and Q. Here P is 5, Q is 10. Right? After writing P and Q, first find integrating factor. What is integrating factor here? So e power integral P dt. Then, so here e power integral 5 dt. So here 5 constant, so into integral dt is t, e power 5t. That is integrating factor. Now the general solution is, what is general solution? So first write formula. So IF is equal to small IF means integrating factor, integral Q into integrating factor dt. Now substitute integrating factor I into integrating factor is e power 5t is equal to integral, what is Q? Q is 10 e power 5t dt plus C. Now here 10 is constant, this is e power 80 form, e power 80 is integration is e power 80 by A. Here we have in place of A 5 plus C, right? Now finally we write e power 5t is equal to 10 by 5 2 e power 5t plus C. So now to get current I, dividing with e power 5t, so I is equal to 2 plus C e power minus 5t. This is I, right? Now use initial condition Sorry, sir.
We'll cut later, no problem. Thank you, no? 25. ఇక్కడ నుంచి repeat
So from the beginning, sir. So I take only 20, not here 20 cos phi t.
మొత్తం repeat చేయండి. This line you are starting now, the previous line నుంచి అక్కడే అటాచ్ చేస్తాం. Okay? From this one, wherever that time will attach.
Okay, sir. Okay, sir. Now and voltage. Now here di by dt plus or resistance is 10 ohms, inductance is 2 Henry into I is equal to here E. So voltage is given 20 cos phi t by L is 2. Right? Now here di by dt plus 5I is equal to, here we get 10 cos phi t. So clear, it is a linear differential equation in I. Now compare with linear differential equation. So then write what is P and Q here, right? Where P is equal to, what is P? Compare with the general equation. So P is 5 and Q is 10 cos phi t. Right? So first find integrating factor. The integrating factor is what is integrating factor? E power integral P dt is equal to E power integral, what is P? P is 5 into dt, so that is equal to E power integral, E power 5 constant integral dt is t, so that is phi t, E power phi t. Right? Now after getting integrating factor, for then right, the general solution is, what is general solution? The general solution is right formula. So IF is equal to integral QIF into dt plus C. Right? This is the general solution for linear differential equation. Now substitute integrating factor E power phi t and Q in this equation. Right? So I into integrating factor is E power phi t is equal to integral, what is Q? Q is 10 cos phi t. Q is 10 cos phi t. Substitute here 10 cos phi t q into E power phi t integrating factor dt plus C. Okay, now here 10 is constant, then here we have E power phi t cos phi t dt plus C. Now integral of this one, now it is in the form of e power ax cos bx form. So e power ax cos bx integration, what is integration? So here write integrating factor, integral e power ax, e power integral ax cos bx dx is equal to e power ax by a square plus b square into a cos bx plus b sin bx. This is the formula for e power ax cos bx. Now here in place of a we have 5, in place of b also 5. Now so using that formula, 10 is constant, compare with that. So e power phi t by a square plus b square, a is 5, b is also 5, so 5 square plus 5 square, so 25 plus 25 into a cos bx, so 5 cos b x. So here function in t, then write a phi cos phi t plus b sin phi t. B is 5. Right, now this from this I is equal to e power phi t is equal to 25 25 50, so 10, so 5 times cancel. Finally what we get here, e power phi t by 5, so take common 5 also actually, then write cos phi t plus phi sin phi t, right. So now to get current, so dividing with e power phi t, so adding plus c also, dividing with e power phi t, we get I is equal to, so here e power phi t cancel, take 5 common, then 5 also cancel, so finally what we get here, so cos phi t plus sin phi t plus, so there is no e power phi t, then dividing with e power phi t we get c e power minus phi t. So this is the current. Now use initial condition, so to find c value, right. What is the initial condition? So when t is equal to 0, initially there is no current, so that means I is equal to 0. Now substitute these conditions in this equation. This is second equation. Substitute that in that equation. So here I is what is I here? I is 0. Then cos phi t, replace t with 0, then cos 0 1 plus here sin 0 0 into the plus c into e power minus 5 into 0. That implies, finally what we get, so here e power 0 1 into cc, here 1, so transpose to left hand side, we get c is equal to minus 1. Then substitute c value in equation 2, so we get a required current. What is required current here? Cos phi t plus sin phi t, so c is minus 1, then minus e power minus phi t. So finally from that substitute c value in equation 2, we get I is equal to, what is I? Cos phi t plus sin phi t plus c. What is c? C is minus 1, so that's why we get minus phi t. This is the required current from given electrical circuit, that is LR circuit. Now I am giving one assignment for you. Note down this. Please note down. An LR circuit has an EMF. EMF means electromotive force given by 4 sin t. A resistance of 100 ohms, and inductance (4 Henry), with no initial current. Find the current at any time t. This is your assignment. So now in next video we will discuss about CR circuit. So that is also one of the application of first order differential equation. Thank you.